Today we are going to discuss about computer networks. Computer networks is a set of computers connected together for the purpose of sharing resources. Whenever network exists, then the data may be sent from one place to another, which is the basic concept of data communication. To fully understand about network, in this video, we first must know about the data communication components, how different types of data can be represented, and how to create a data flow. So here, what is a data communication? That is, when we communicate, we used to share information. The sharing can be a local or remote. Between individuals, local communication usually occurs face to face. That is when we are talking directly to each other in the same location. Whereas remote communication takes place over a distance. That is, either we talk through a telephone or when we watch a television, we call it as a remote communication. So like here we are going to share the data. Wow, what is the data? The data is going to be referred as information presented in whatever form is agreed upon by the parties creating and using the data. So in data communication, we are going to exchange of data between two devices via some form of transmission medium. For data communication to occur, the communicating devices must be a part of communication system made up of combination of hardware and software. So before we are going to see what are all the components of data communication, we will see the effectiveness of communication. It depends on four fundamental characteristics. They are delivery, accuracy, timeliness, and jitter. So what is a delivery? The system must deliver data to the correct destination. Data must be received by the intended device or user and only by that device or user, which we call it as delivery. Accuracy. The system must deliver the data accurately. That is, the data should not be modified or altered during the transmission and left uncorrected or unusable. The third one is timeliness. The system must deliver data in a timely manner. If the data delivered late, then it is useless. It is the best case if you consider video and audio. Timely delivery means delivering data as they are produced in the same order that they are produced and without significant delay. This kind of delivery is called real-time transmission. And the last one is jitter. Jitter refers to the variation in the packet arrival time. It is the uneven delay in the delivery of audio or video packet. For example, let us assume that video packets are sent every 30 milliseconds. If some of the packets arrive with 30 millisecond delay and the other with 40 millisecond delay, an uneven quality. In this, the video results very poor quality. So these are all the four fundamental characteristics which deals with the effectiveness of data communication system. So now we are going to see the components of the data communication system. Here we have 5 components. The first one is message, sender, receiver, transmission medium, and protocol. These are the basic 5 components we are going to used in data communication system. So first we will see one by one. The first one is message. The message is the information or data which is going to be communicated. The popular form of information includes text, number, picture, audio, and video. So the message is going to be the information which is going to be used for communication. The next one is sender, and the third one is receiver. So here the sender is going to be a device that sends the data message. Similarly, the receiver is the device that receives the message. It can be a computer, workstation, telephone headset, or video camera, and so on. The sender and receiver are the devices which is going to send and receive the message. Transmission medium. The transmission medium is the physical path by which a message travels from sender to receiver. For example, if for a car or a bus, the transmission medium, we call it as road transmission. If for aeroplane, we call it as air transmission. Here we are going to use some physical path where the message is going to be traveled from sender to receiver. Some examples of transmission medium includes twisted pair wire, coaxial cable, and fiber optics, radio wire, radio waves, etc. The last component of data communication is a protocol. A protocol is a set of rules that govern the data communication. It represents the agreement between the communicating devices. Without a protocol, the two devices may be connected, but it is not communicated. Like if one is person speaking in English and the other is speaking in Japanese, then both cannot understand the languages. So these are the some basic components which we are going to be used for data communication. Next, we are going to see how the data are represented. Data can be represented in different ways such as text, numbers, images, audio, and video. We will see one by one. Text. The text is represented as a bit pattern. That is a sequence of bits containing zeros and ones. Different set of bit patterns have been designed to represent text symbols. Each set is called code, and the process of representing symbol is called coding. The American Standard Code for Information Interchange, that is ASCII code, which uses 32-bit to represent a symbol or character used in any language in the world. The next one is a number. The number is also going to be represented by a bit pattern which contains sequence of zeros and one. However, here we are not going to use any code such as ASCII. We are going to represent the number which is directly converted to a binary number to simplify by using some simplify mathematical operations. Image. Here image are represented by a bit patterns. In simplest form, the image is composed of matrix of pixels, where each pixel is a small dot. The size of the pixel depends on the resolution. For example, an image can be divided into 1000 pixels or 10,000 pixels. If in the second case, it would be a better representation of the image, but it will occupy more memory. After an image is divided into pixel, each pixel is assigned a bit pattern. The size and the value of the bit pattern depends on the image. So here we have shown example for black and white image. We can also have the color image, and we have several methods to represent color image. One method is called RGB. It is called as RGB because each color is made up of the combination of three primary colors, red, green and blue. The intensity of each color is measured and a bit pattern is assigned to it. We also have another method is called YCM, in which a color is made of combinations of three other primary colors, yellow, cyan and magenta. Next one is audio. Audio refers to the recording or broadcasting of sound or music. Audio is by nature different from text, number or images. It is a continuous, not discrete. Even when we use microphone to change voice or music to electrical signal, we create a continuous signal. The last one is video. Similarly, the video is also the recording or broadcasting of a picture or a movie. Video can either be produced by a continuous entity such as TV or camera, or it can be a combination of image, each a discrete entity arranged to convey the idea of motion. So here we have 5 different types of representation: text, number, image, audio and video to represent the data. Now we are going to see how the data flow in the communication part. We have half duplex or full duplex. In simplex, the communication is unidirectional. That is a one-way communication. Only one of the device on a link can transmit, the other one can only receive. That is, when you see in this figure, the A can only transmit the message and B can only receive the message. It is like one-way street. We have many examples. Keyboard, monitors are all examples of simplex device. Here I saw one small example using television. So here we have a television and a man watching the television. So we have a receiver and a transmitter. But when you see the flow of the communication, always occurs only in one direction. That is, the message can be sent from television to the man. The vice versa is not possible. So this type of communication is known as simplex communication. The next one is half duplex. In half duplex mode, each station can both transmit and receive, but not at the same time. That is, when one device is sending, the other can only receive, and vice versa. The half duplex mode is like a one-lane road with traffic allowed in both directions, where cars are traveling in one direction, car going the other way must wait. In half duplex transmission, the entire capacity of channel is taken over by whichever two devices transmitting at that time. The best example for this is walkie-talkie. So I have shown example here. Here again we have a sender and a receiver, and I have shown the communication. But when you see clearly, when we use this device, either you can talk or you can hear, but you cannot do both the process at the same time. That is, either you can send the message or you can receive the message, but both cannot be done at the same time. So this is what the example known for half duplex communication. The next one is full duplex. In full duplex mode, both station can transmit and receive simultaneously. The full duplex mode is like a two-way street with traffic flowing on both the direction at the same time. In full duplex mode, signals going in one direction share the capacity of the link with the signal going in another direction. This sharing can occur in two ways. Either the link must contain two physically separate transmission paths, or it may have some channel where they can share. The best example for this is telephone network. So here I'm showing mobile phone. Again, we have a sender and receiver. But when you see here, at the same time, you can talk and listen. It is not like walkie-talkie where we can either talk or listen. But in this device, if you use this device, you can talk parallelly, you can also listen. So this is what known as full duplex communication, where both can send and receive simultaneously. So we have now we can conclude the session. So here we have discussed about what is data communication, what are all the basic components of data communication. So we have seen 5 different components we have, and how we can represent the data, and what are all the different way of data flow between sender and receiver. Thank you.